So scan the lesson, predict 2 things we're going to learn about appropriate measures. That's chapter 11, lesson 5. So we're going to learn measures of center. So that's mean, median, and mode. Aren't always appropriate. We will learn how to choose the appropriate measure of center. I can't even spell. Appropriate measure. So real world link. So we're going to be looking at recycling. So find the mean weighed calculated. So if I add all these numbers together, I have 11 plus 13 is 24 and decimals. So 11 plus 13 plus 12 and 2/10 plus 19 and 5/10. It's 55 and 7/10. Now, since there's 4 numbers, we're going to divide by 4. So we get 13 and then 925 thousandths. If the newspapers are not included, find the mean weight rounded to the nearest tenth. Okay, finding the mean again without the newspapers. So we have 12 and 2/10 plus 11 plus 13. Now, since there's only 3 numbers, now we're going to divide by 3. So we have about 12 and 7/100th. So that's the average weight without the newspapers. So how does the weight of the newspapers affect the mean? So it causes the mean to be about 2 pounds heavier. What is the median for the data set? So the median, so if we take these from least to greatest, so we have 11, 12 and 2/10, 13 and 19 and a half. We take the mean, the median, so that's 12 and 2/10 plus 13 divided by 2 is 12 and 2/10 plus 13 divided by 2 is 12 and 6/10. So the number in between these, so the median is 12 and 6/10. So how does the median differ if the newspapers are not included? So if there's no newspapers, now the new median is 12 and 2/10. So the median is 4/10 pounds less if the newspapers are not included. And then we'll go into more detail. Well, I'm actually going to refer back to this. So it says we have to learn when to use the appropriate measures. So mean, we're going to use mean when the data has no extreme values. We're going to use median when the data has extreme values. There are no big gaps in the middle of the data. Mode is when we have many repeated numbers. Okay. Sometimes one measure is more appropriate than others to use. So that's what we're going to find out. Example 1. The table shows the number of medals won by the United States. Which measure of center best represents the data? Then find the measure of center. So here's all the numbers. Since the data set has no extreme values or numbers that are repeated, the mean would be the best one. So when it says no extreme, that I think what they're saying is there's no outliers. So we don't have, in 2009, if we had one person get a medal, then that would interrupt the entire average. So that's what they mean by extreme values. There's no extreme values, and there's no numbers repeated, so we're going to use the mean as the best way to show the measure of center. So when we use the mean, on average, we got 104 3/5 medals. Example 2. The data shows the water temperature over several days. Which measure of center best represents the data? So 82, 82, 85, 82, 82, 78, 81. Now if you notice, 82 is there 4 times. So it's safe to say we're going to be using the mode. So there's no extreme values, and there's a temperature repeated 4 times. So the mode 82 degrees is the measure of center that best represents the data. So we had about 82 degrees a majority of the time. So example A, the prices of several DVDs are $22.50, $21.95, $25, $21.95, $19.95, $21.95, and $21.50. Which measure of center best represents the data? Justify your selection and find the measure of center. So if you notice, $21.95 has been repeated. We have 1, 2, 3 times. So we're going to use mode and $21.95. Because mode is a good representation that all the DVDs are about $21.95. So mode, because it is repeated 3 times. So now we're going to be looking at outliers and how outliers affect data. So an example, the table shows the average lifespans of some animals. So we have 35, 30, 50, 200, 30, 70, and 20. Obviously, the number that stands out is 200. 200 is way higher than all the other numbers. So we're going to say 200 is an outlier. So that's just identifying the outlier. Now that we've identified it, let's see how it affects the mean, median, and mode. So if you look at it with the outlier, so with the age of 200, the average lifespan of all the animals is 62. Now, if you look at the numbers, is it fair to say that on average, all these animals age to 62? Not really, because we only have two animals that even get close to 62, maybe 3. But so that's how the outlier kind of interrupts the data. If you look at the median, we have 35 and the mode is 30. Now let's look at the data without the outlier. If we look at the average, so the mean, so on average, the animals all have a lifespan of 39 years old. If we look back up here, that is a better answer. So almost all the animals have a lifespan of about 40 years. And that's not including that one. So that's a better representation. So since we know that there is an outlier, in this case, we're not going to use the mean to represent the measure of center. Now, if you look at our median, we have 32.5. So 32.5, and it used to be 35. And if you look at the modes are the same. So the outlier mostly interrupts the mean. It really has a big difference on the mean, but not much of a difference on the median and no difference on the mode. So the mean lifespan decreased by 62 minus 39, or 23 years. The mean lifespan decreased by 2.5 years. The mode did not change. So the whole average changed by 23 years. So that's a pretty big gap for an average change. So example 5. Which measure of center best describes the data with and without an outlier? Justify your selection. So the mean was affected the most with the outlier. The median lifespan changed very little with and without the outlier. So in both cases, so it best describes the data in both cases. The mode does not describe the data very well since there are only 2 repeated numbers. So mean, we're going to say no. The outlier changed the mean too much. Median was about the same, so that's good news. And the mode it was only appeared 2 times. Now, if 30 appeared, let's say 6 times, 5 times, then the mode would be a good representation. But it only appeared twice. So in this case, the median was the best representation because on average, 35, 32 and a half lifespan, that works. So we're going to try the got it. So we have B, C, and D. So first we have to identify the outlier in the data set. So if we look here, we have about 50, close to 50, close to 50, close to 50, and this is close to 50. That's close to 80. So when we identify the outlier, we're going to say the outlier for B is $78.95. So determine how the outlier affects the mean, median, and mode. Well, it's kind of obvious. The outlier affects the mean. The median is only going to change a little bit. Was there a mode? And no mode. So which one is going to be the best one? The median. Because it doesn't change much. Was affected the least. So it is the best measure to use. So this whole entire lesson is just basically saying which one is the best one to use, the mean, median, or mode. And that's the end of the lesson, so thank you for watching.